Today we're working on section 6.2 of the Green Pre-Algebra book on how to factor a difference of squares. Back in chapter 5 we learned how to multiply two binomials that would give us a result that were a difference of squares. So when I'm multiplying x plus 3 times the quantity of x minus 3, we can use our shortcut knowing that we will end up with x squared minus 9. If you forget how to do this, go back to chapter 5, I believe it's section 510, and watch the video there. So number 2, when we shortcut it, it will be m squared minus 49. Square the first term, square the second term, and we actually eliminate the two middle terms, so we have a y times y is y squared, positive 10, negative 100. And number 4 is t squared minus 64. So what we're going to do now, we're actually going to start with these products and find the numbers that make the two factors that multiply together to give us the product. For example, if I have the number 6, I know that 2 times 3 are two factors that multiply to 6. So what I'm looking for here now is when I have the product x squared minus 9, I'm looking for two numbers or two things that multiply, two factors that multiply to x squared minus 9. So the first thing you're going to do is create two parentheses for binomials. I'm going to take the square root of the first term, and that's an x. Place it in each binomial. The square root of 9 is 3. In order to get that negative 9, I have to have a positive times a negative. And now you've got the two numbers, the two factors that multiply to the product x squared minus 9. And that's all there is to it. So when I factor m squared minus 49, okay, again, make my binomials. I know m squared, the square root is m. I know 49, the square root is 7. I know in order to get that negative 49, I've got to have a negative and a positive. I generally try and put my positive first and my negative second. The value is still the same. It would be correct, but if I have more factoring to do, I want more factoring in that direction. So that usually comes when I'm left with another negative. So pause the recording and factor number 3 through 7. Okay. All right, now check your work. Y squared minus 10 comes to y plus 10 times the quantity of y minus 10. T squared minus 64 comes to t plus 8 times the quantity of t minus 8. X squared minus y squared is equal to x plus y times the quantity of x minus y. 16 minus k squared. Now this gets a little tricky. Square root of 16 is 4. How do I get that negative k squared? I have to keep it in the same order. So the 4 is placed first for the 16. And remember, to get that negative k squared, I have to multiply a positive k times a negative. So yes, you have to keep it in that second position, or just make it negative if you place it in the first position in the binomial. And number 7 is p plus 1 times the quantity of p minus 1. All right, so now we're going to actually get to factoring. When you're factoring, that was one form, and that's called a difference of squares. But before we ever do that, we always have to pull out our GCF. Now, before I kind of mix the two levels, I want to go back and review, because in order to do a difference of squares, you have to recognize them. So let's take a minute and look at the pattern. Okay. First of all, we have, if I have a squared minus 25, that is a difference of squares. This only works when you're going from a difference of squares. So most of the time, we factor trinomials. This is one of the few binomials that we can factor into two binomials. This is one of the few, it's with two terms that will give us two binomials. So let's look. And the pattern is, it's a perfect square minus a perfect square. If you see a plus sign in the middle, it's not a difference of squares. If one of those terms is not a perfect square, it's not a difference of squares. So let's look at what are our perfect squares. You should know them through 20, and then you should know 25. So when I, actually 0 is a perfect square. It's not on here, but you do need to know that. So 0, I'll add that afterwards. 0 is a perfect square, and that would be 0. 1 squared would be 1 is a perfect square. 2 squared makes 4, so 4 is a perfect square. The next one would be 9. That comes from 3 squared. The next one would be 16, then 25, then 36, then 49. The way I'm getting these is I'm just squaring the numbers in order. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So after 49, we have 64, then 81, then 100. That's 10 squared. 11 squared is 121. 12 squared is 144. Now 13 squared, must know this one. It comes up a lot. 169. 14 squared, 196. 15 squared, 225. Whoops. Let's go back. I want you to add that to your list. 15 squared is 225. 16 squared is 256. 16 squared is 16 squared. It was 256. 17 squared is 289. 18 squared is 324. And 19 squared is 361. And then we have 20 squared is 400. And I want you to make sure and know that 25 times 25 is 625. Okay. Again, let's make sure you know that 0 is a perfect square. So I added that on the other side right near the 1. Okay. Questions? Oh, can't take questions. Sorry. All right, so let's move on now. All right, so now let's get started factoring. Remember, we're going to start with our two. We're going to start with our 2 parentheses. Okay, so the square root of x squared is x. I'm placing it in the first space, just like this is in the first space. Square root of 81 is 9. And to get that negative 81, I'm going to have the positive and the negative. All right, let's move on. Now don't be worried. I know you're seeing this coefficient here. Remember, if it's a perfect square, 9's a perfect square, and that's 3. M squared is a perfect square, that's m. And then I've got 121, which is 11. In order to get that negative, I have to have a plus and a minus. Now pause the recording and do numbers 3 through 8. All right, now check your work. So for number 3, we get 4 plus 7k times the quantity of 4 minus 7k. Number 4, we end up with k squared plus 2 times the quantity of k squared minus 2. Couple tricky ones in here. and number 5 is one of them. Remember, the rule for factoring a difference of squares is both numbers have to be perfect squares. 50 is not a perfect square, so in this case, it's not factorable. Okay, 4x squared minus 49 becomes 2x plus 7 times the quantity of 2x minus 7. Number 7, there is going to be 6y plus 1 times the quantity of 6y minus 1. Number 8, I know it looks like a perfect square, again a tricky one, but remember a difference of squares must have two perfect squares and a different sign. Perfect square, but it doesn't have the different sign. So in this case, this is non-factorable. So remember, we can the only binomial we can really factor is the difference of squares, unless you're just pulling out a GCF out of just general factoring. All right, so let's move on. Let's make it a little bit more complicated and let's mix a couple things. Now remember, the rule for factoring is you always pull out your greatest monomial factor first, your GCF, and then you break it down as much as you can. But first step, pull out your GCF. So in number 1, it doesn't look like a difference of squares, but I do have a GCF of 2. So I'm going to divide out the 2. And now I'm left with x squared minus 25. What do you know? I'm left with a difference of squares. So I bring down the 2, and now I'm going to factor x squared minus 25, and I end up with x plus 5 times the quantity of x minus 5, and this is the final answer for factoring 2x squared minus 50. Now, number 2 is pretty tricky. They don't, it doesn't look that tricky, but let's look what happens. All right, so I'm going to factor. Remember, I make my 2 parentheses. The square root of m to the 4th is m squared. And remember, the square root of 1 is 1. I'm going to have plus 1 and minus 1. Now, with the first term, m squared plus 1, I'm done. That can't be factored anymore. But look what I'm left with, a perfect square minus a perfect square. So that can be broken down further to m plus 1 times m minus 1. And don't forget your original term, m squared plus 1, because all 3 are the full factored form of m to the 4th minus 1. This gets especially tricky when you get something like x to the 16th minus 1. There are quite a few difference of squares within that you will have to factor out. All right, make sure and take those notes, and let's practice. All right. I'm going to leave it here for a minute if you want to write down the directions. Now, let's practice number 1 through 4. I'll do the first one with you, and you guys can continue. So on number 1, I'm going to factor out, remember we always start with the GCF. Number 1 mistake that algebra students make. Start with your GCF. So in 3y squared minus 27, I can pull out my GCF of 3, and then I'm left with y squared minus 9. Now, y squared minus 9 is a difference of squares, so I get 3 times the quantity of y plus 3 times the quantity of y minus 3. Now you guys try 2, 3, and 4. Pause the recording. All right, now check your work. X to the 4th minus 81. That breaks down to x squared plus 9 times the quantity of x squared minus 9. Now, can x squared plus 9 be factored? No. It's not a difference of squares. Only one that can be factored out more is x squared minus 9, and that breaks down to x plus 3 times the quantity of x minus 3. So I get x squared plus 3 times the quantity of x plus 3 times x minus 3. And that's our final answer. Number 3, divide out our GCF, and I'm going to divide by 5, and I'm left with m to the 6th minus 4. M to the 6th breaks down to m to the 3rd plus 2 times the quantity of m to the 3rd minus 2. Now, this is not a perfect square, this difference of squares. The m to the 3rd, there's no number times itself that I'd get m to the 3rd. So that's as far as we can go. Number 4, I'm going to divide out my GCF of 5. I'm left with 5 times the quantity of y to the 4th minus 16. Y to the 4th minus 16 breaks down to y squared plus 4. Now remember, that first one doesn't break down anymore, y squared plus 4, but y squared minus 4 breaks down to y plus 2 times the quantity of y minus 2. So the final answer is 5 times the quantity of y squared plus 4 times the quantity of y plus 2 times the quantity of y minus 2. Now, I believe that's it for the lesson. So please make sure you have all your notes and show them to your teacher if you've been absent.